Hello everyone, in this video I'm going to show you how to work with new Python patch-based inference library, and also this library was created for visualizing your inference of pre-trained and also custom trained YOLO models. So let's speak in this video about visualization of your inference. So during this video we're going to speak about this Jupyter notebook, which is the second one. You can press it and look exactly what we are doing. So I will open my VS Code. Here I have this example Jupyter notebook, and let's try to install our Python package. For installation of our Python package, we just need to create a new Python environment. For example, in my case, I have test lib environment, and here we need to pip install patched YOLO inference. This one, pip install patched YOLO infer. Be careful if you have CUDA version. If you have possibility to use PyTorch with CUDA. So first of all, before installing my package, you need to go to pytorch.org and here download the Python version for with CUDA. So this PyTorch version with CUDA, for example, this one with CUDA 11.8, and only after that, after you have already downloaded this Torch version, you can specify this new Python library, this one, pip install patched YOLO infer. Press enter, wait until the end, and let's go. So we're ready. I will close my terminal, and here in environments, I have already chosen test lib Python package. Test lib environment. So let's specify all imports. Here we're going to use CV2, matplotlib for visualization, also Ultralytics. From Ultralytics we will get YOLO, and also NumPy. That's all, nothing more. And here we download, visualize results usual YOLO inference, and also get crops, two extra functions that we get from my new module. So let's speak about visualizing results of YOLO inference. So there are a huge amount of different parameters that we can give inside of this function. I will try to show you in examples so you will get this information more clear. Okay, so first of all, we need to specify the path for our image. So in my folder here, you can see test.jpg. So we open this image. Right now, this image is in BGR format just because of CV2. And here I visualize my image using transformation from BGR to RGB just for better visualization for us. So let's work with YOLO segmentation model. When we want to work with segmentation model, we just need to specify the path for this model. So model is YOLO, and then we pass weights. If we pass weights like in this example, that's going to be pre-installed weights of YOLO, so they will download automatically. For example, I will show you in this folder. I can, for example, delete my weights, but after pressing this button, this weights are going to be downloaded automatically just because they are pre-installed for YOLO. So look at this. Right now we have this weight again. Okay, here we specify some parameters for inference. I mean intersection over union for non-maximum suppression, and also confidence for showing only confident results. So here we specify in my function image, it's BGR NumPy array, also model, right now it's YOLOv8 segmentation model, image size, as usual, it's 630, it's predefined parameter for YOLO protein models. Also confidence, intersection over union that you want. And also after that, you need to specify what do we want. We want to segment or detect. If we press true in segment, this model is our inference is going to be specified for segmentation task. So we will get exactly masks that we need. After that, I will show later, we have delta. Colors, thickness, it's for thickness of our bounding boxes and our tags and so on. Font scale, it's for visualizing text. Also, show boxes, it's about visualizing boxes. Fill masks, it's about filling masks inside. Alpha is the percentage of this filling masks, how this is filled. Also, random object colors, I will also show you later. Show confidences, I will also show you later. This is for visualizing not only class, but also visualizing confidence of this class. And DPI, it's parameter for better visualization. So when we increase DPI, we get bigger image as a result. If we decrease it, we get smaller. So let's press and find out what is happening. Look at this. This is a result that we got. So here we have these contours. Inside of these contours, we get filled mask with alpha is 0.3. So let's predefine it as 0.7. Press enter. And now we see that it's not so transparent as it used to be. So it is just the quality of transparency. Let's decrease it for 0.4. Also, look at this. Right now, we get the class and also the confidence score. If we want to get rid of confidence score, we all need to do is to show confidence false. For example, like that. Also, let's increase DPI, for example, 150. In that case, we will get bigger result at the end. Look at this. Now our result is much bigger. We don't have any confidences. We just get result with classes and masks. So let's define show boxes equal to true. In that case, we will get not only our contours, but also bounding boxes around of our contour. Sometimes it may be useful, so we give this possibility for you to use. By the way, maybe you know this or not, but all segmentation, all instance segmentation, is detection and after that segmentation. That is why if we define segmentation equal to false, our model, model YOLOv8 segmentation will be the same as YOLOv8 usual. So it is going to be detection task. Yeah, maybe not so accurate as usual YOLOv8, however, it's going to be detection task. So let's press. And now we see that our model is, our inference results looks the same as usual YOLO inference without any masks. So it's also possible to get rid of masks and do not show them at all if you don't want them. So it's your own choice. Also, look at this. Right now, all our classes have different colors. Just because I don't really know how much colors, how many classes do you have in your task, your specific task, if you have your specific model. That is why we define colors randomly. So all colors for each object is random. So that is why you can work with this seed. You can change colors just changing this parameter, delta colors. Right now it's 3 because I defined that it's pretty it's simple, it looks not so bad, so why not 3? Let's press 5 and look at this. Right now colors are different. I will show you, for example, 8. Let's press. Look at this. Now colors are different. Let's press, for example, 80. I don't know. It's a seed of random. Now colors are different once again. For example, right now bass is pink. Cars are green. However, it used to be when it was 3 like that. Okay, I think you now understand the idea, so you can just check it, find out what do you want. So you have a huge amount of customization just for visualization of your results. And this is the most important aspect that we want to give you with this Python package. So just try, check, and get your own specific results. So also, you can change the size of a result. For example, here bus maybe is so small for you and you want to see it bigger. So, okay, in that case, we need to, for example, increase thickness. Let's press 3, and also font scale. Maybe we can make it bigger, for example, 0.9. So in this case, the font is going to be higher, and also the thickness of all boxes, of all things inside of this processed image is going to be bigger. So it's maybe going to be more comfortable for further analysis. Let's press. And now we get bigger text and also bigger boxes. Okay. So I think now you understand the idea. So also we can specify true here. Let's come back to usual segmentation visualization. Let's turn off visualization of boxes. So I don't think that we need them anymore. Let's press once again. And here you are. Okay, maybe show boxes. No, show boxes is equal to false. We don't want to see boxes at all. Let's press. So yeah, here you are. We don't have boxes, only masks, and that's all. And also this information about the class. What else can we do? For example, I want each object to be in their unique color. For example, I want somehow to show to my, I don't know, audience or someone else that look at this. It's not a usual semantic segmentation. It is instance segmentation. So each object has its unique color. So, okay, not problem. In this case, you just need to initialize random object colors equal to true. So that's why each object is going to have unique color. Let's press. And here we are. Each object has its unique color. Okay, for example, you don't like this visualization. Maybe you want to change something in your seed. I just remind you that delta colors is also possible for you. So press 0 and look at this. Now we have different colors. So just work with that. Maybe it's going to be comfortable for you. For example, if you don't really want to see information about the car or something else about the class, we can just delete it. It's not a problem. How to do this? In my case, you need to specify the parameter which looks like class. I think show class. Yeah, show class. Show class equal to false. Equal to false. Show class, like this. So in this case, we're not going to show class anymore. Look at this. Right now, we don't have any information about the class, just each object with its different colors. We can come back and make it not different. For example, let's press it false. And this is the final result that we get. You can say, oh, okay, but where are cars? They used to be here. Don't worry. It's just because of not really good random seed. So here the color is close to black. Okay, let's check, change delta colors for 4, for example, I don't know. Press once again, and now we get better visualization. So you can customize it for your needs, change everything that you want, and get your own specific results for this start. It may be detection, it may be segmentation, anything. So you see the customization is incredibly huge. Okay, that's it. So also, what can I show you? We can press fill masks equal to false. In that case, we will just get contours, not filled stuff. So here we just get contours, not filled aspects inside of these contours. Maybe sometimes it's going to be also really comfortable for you. Okay, what else? The last aspect that you need to know is this function. It's not only visualizing in matplotlib plot form. So this function right now is not returning anything back. It is just visualizing our inference. It's comfortable maybe for some investigation, for some research inside of Jupyter notebooks. However, if you want to use our visualizing function in production, for example, for visualizing something, it's not a problem to specify one extra parameter. Information is over here. It's return image array. Right now it's false. It means that this function does not return any NumPy array. But if you press return equal true, in this case, this function is going to return something. For example, I will show you example. So if we specify result equal to, and then this function, but right now, we need to specify one extra parameter, which is return image array equal to true. Like this. So if you press, you will not get anything here, so no visualization at all. However, you will get BGR NumPy array as a result, and you can use it somehow in production in some further, I don't know, researches and so on. So it's just for you. Okay, let's see other examples. So here I specified some example. Here we don't fill anything inside. We just show only class without confidence. We also show boxes around. Each class has their unique color. And not only class, I think all objects have their unique colors. So it's just because random object colors equal to true. So look at this. Okay, for example, YOLOv8 detection. The same aspect. You just initialize model. For example, model YOLO is equal to YOLOv8 PTE. And after that, you specialize some information about this function. Press enter. Also, you need to specify that segment is equal to false just because YOLOv8 has no segmentation inside. So that is why segmentation should be equal to false. And now you can choose everything that you want. You just need to read all this documentation. Here you are. There are a huge amount of different parameters that you can change, and you will get better results. For example, you can show axis if you want. I don't know why. Maybe you want. Also, you can specify font. So for example, if you want to change the font of your text, by the way, it's possible for you to change the class background. Right now, all our information about classes are, look at this, are red. So this color is red, is predefined color. However, if you don't like red, maybe you want blue, black, white, I don't know, everything. It's not a problem. You just need to specify color background and give it in BGR format. For example, 255. It means red channel is maximum, so it's red. The same aspect for text. For example, you want text inside of this box to be not white as it's predefined. For example, black. So okay, that's not problem. Change color text and get all you need. So this is really comfortable for you to do everything without really understanding how it's working. Just read this documentation and work. That's it. Okay, so YOLOv8. This is an example of visualization. This is another example of visualization. Also, look one more thing. For example, my model is detecting multiple classes, but I want to visualize only some of them. For example, my usual pre-trained YOLOv8 model is detecting, as I remember, 80 classes of co-coded dataset. However, I can show only, for example, cars or only people, cars with people, and so on. So here we need to specify the list of indexes of wanted classes. For example, show classes list. Here we specify and just press enter. Let's show. For example, I want just to find 1, 2, 3, 4, 5, 6, 7. This list starts from 0, where 0 is people. So look at this. Now we get everything except for people, just because people are not in this list. However, if I put 0 inside and press once again, we get people just because people are also the class that we can specify. For example, right now we don't get any backpacks. However, before we had this handbag. Look at this. All detections were also possible for this class. For example, we don't want to find information about this backpack, so just get rid of this class and visualize everything except for this unique class. So it's also one more possibility for visualization and your further analysis. Also, except for this visualization tutorial, I'm going to show you one more function that you can use for your training process. For example, you have a really huge image, and you want to train your custom model for detecting some sort of small objects. Of course, it's not a good idea to upload full image. It's much better to upload some crop of this image. So you need to make a huge amount of crops and then upload these crops, for example, to CVAT. And in this computer vision annotation tool, you just need to label all these boxes, not for all image, just for this small crops. Sometimes it's a really important aspect, especially when you work with small objects. For example, I don't know, stones, some maybe small, I know, you can just create your own, maybe some small bubbles and so on. So here we specify function for getting crops. Here, we just need to give an numpy array. It's bgr numpy array of the image. Also, we need to specify what is the shape of x of crop, shape of y. So the width and height of the crop. And also overlap percentage. So we can just borrow some information from previous crop just because of initializing higher percentage of overlapping. So for example, if we press 50%, in this case, we will get 50% of the previous crop. Let's look at the example. Here you are. We have some image. We open this image using CV2, and after that, we specify this image. Also, a shape of x-axis is 300. The y is also, so the crop is going to be as a rectangle. No, rectangle, I mean square. Also, overlap of x is 50%, overlap y is only 10%. Look at this, when we press, we get this image. We can see what exactly is doing. So he is cropping, and we get a huge amount of crops. For example, if we decrease the amount of the overlapping parameter, for example, we can specify 0. Right now, we get not so huge amount of crops, just because the next crop, like from the right one, is not getting some information from the left one. For example, if we press overlap 70%, let's press. Now we see that this crop and this crop, they borrow the same information, like 70% from the left one. Next one, the right one, is borrowing. So it's maybe useful to get more crops sometimes for your task. For example, you don't have so much data and you need to somehow increase this data just because of changing the overlapping parameter. It's maybe a really good idea for you. How to save this crop results? It's pretty easy. You have this possibility, save crops equal to true. Let's specify true. When we press true, here we have, for example, start name. The start name is img, so image. When we press, right now from the left side of our working directory, we see that we have this result. So we got 20 generated images, and here you are, all 20 images. You can look, they are here. So right now, you just need to take them and upload them to CVAT for further labeling. And this is pretty easy to do. For example, right now, let's change somehow, and shape X, for example, is going to be 400. However, Y is only 200, like this. Overlap is going to be, for example, 50. Why not? And let's start name is going to be not image, but new. I don't know, why not? So here, we are going to add extra photos. So this folder is going to be increased in size and not going to be overwritten. So let's press. And right now, we see this visualization. And here we get not only image crops that were square in a square form, we also get these rectangular crops in a really huge amount. So 35 rectangular crops we get from one specific image. Of course, it's just an example. You can use it in your specific task. Maybe you know how to use it much better than me. After the end of this procedure, you can find out that the output, so data all crops, this output of this function is just a numpy, is a array. So if we specify as numpy array, we see that the first channel is 35, so it's amount of crops, and after that it's width, height. I mean height, width, and also channels. In this case, BGR. So yeah, that's right. Also look at this example. It's without any overlapping example. Here we see with huge overlapping example. Also, we have parameter show. If you don't want to see anything, just press false. In this case, this function is going to work, but no results are going to be shown after the end of this procedure. And the last one, extra content for people who have patience and waited until this moment. This method of visualization that I was showing you before, it's not only for YOLOv8. This visualization works with anything from Ultralytics. For example, YOLOv9, also fast SAM, and also real-time detectron, so RTDETR. Let's look at the examples. For example, we can specify fast SAM, it's segment anything model from company Facebook. And here, when we press, we get this pretty beautiful example. It's example of segmenting everything in this image. You can specify your task and maybe use it somehow, I don't know, in your production case. But this is a pretty comfortable way of visualization without any problem. So you don't need to check all literature and find out documentation. You can just specify model and then specify the predefined parameter that I have already shown you how to work with. Also, let's see how to work with YOLOv9. It's pretty easy. Just specify YOLOv9 and work the same as YOLOv8 usual detection model. So segment equal to false and just specify everything and you get the same results, but with not YOLOv8, but with YOLOv9. So pretty easy. The same stuff. Working with YOLOv8 and V9 is the same. Just choose what you need. And the last one is real-time detectron. It's a detection transformer. Detection transformer is sometimes a really good way to choose in your project. So look at this, how it works. When we press enter, we get the result of RTDETR, and it looks pretty good. Not really better than YOLO, but I think sometimes it's maybe better than YOLO in some sort of cases. So thank you so much for watching this video. I hope my Python library is going to help you in your visualization tasks of YOLO or different Ultralytics models. So just check my documentation. You can find everything here in my GitHub page of this project. Also information of downloading, some collab examples, and also some videos that you can also check. This video that I was explaining you was video about visualization, so number 2. If you want to know how to use patch-based inference, I mean it's inference for huge images where we have really small objects. Look at this example. So usual, this image, this is the usual basic inference of YOLO, and this is a patch-based inference. So we get much more results because of patched-based algorithms inside of visualization and processing of your input image. So I will explain you how to work with that in the next video. So just press and see how it works. For example, this was a good example. Usual inference cannot find anything. However, our patch-based inference is the best approach in this task. So with all Ultralytics models, you can use our library for not only patch-based inference, however, for usual inference visualization of YOLO and other models. So I hope now you understand how. Good luck. See you in the next video.